We're going to build in this video an analog combination lock, and the concept behind this is that we're going to lock a circuit. This could be used to make a mechanical lock, but you would need to use a solenoid to unlock the mechanical locking mechanism for that to work. But this is more to lock a circuit and make it so that you can stop a pulse of electricity unless the right combination is entered. We're going to be using a 4-key system where 2 of the keys are required to be down and 2 of the keys are not allowed to be down. By enforcing certain ones that are not allowed to be down and by requiring that certain ones are, then we've really enforced with 4 keys they have to each be in the position that they're supposed to be in, which means that you've only got 1 in 16 chances of getting the combination right with a guess. And the system we're going to use, I'm just demonstrating how to add things that are required to be pushed and how to add things that are canceling, but you can add more to it with the process that I made, and you can have theoretically billions of different keys, and you can replace these keys with anything else that switches a circuit. So you can have switches, you can have motion sensors, you can have light sensors, laser beams, whatever you can have as a switch, you can have as a part of this combination. So the point is that you're making it so that certain things have to be in the correct order for something else to get electrical power. So that's what we're locking, is we're locking the electrical power. But we could also lock, for example, the solenoid on a mechanical lock and then turn it into an actual physical lock as well. But in our case, we're just going to be turning on an LED with 4 keys, but they have to be in the correct position. So here is our combination lock, electronic combination lock, and the power comes in to these switches here. These 2, as you can see, they are wired up as a series wiring. So this button has to power that button. That's what we're talking about by series. And then over here we got 2 parallel wired buttons, which means either one of these will charge this line. This one, it requires both. So what we've done is we have it to where both of these have to come down without either one of these. So only if these 2 buttons are down and these 2 buttons are not down will the lock be open. Otherwise, it's not going to be, we're not going to turn on the light. That's what we have over here, is we have the light wired up. So how we did this, and if I was actually going to do this, I would actually use smaller components than a relay probably. But the relay makes it easier to understand on the videos, so that's why I used a relay. I like to use those on my videos for this. So these guys here provide the power. All of my ones that have to be down there in series wiring, and then they are asked over here at the relay. They're going to try and pass power through the relay, which normally would be closed unless either one of these buttons is pushed. Then we're canceling it out. So these 2 cancel out. Either one will cancel out, but both of these are required to send the charge through to my light. So now that I've explained how that works here, we're going to demonstrate that. So, no one key will turn on that light. These 2 are both required to do it together, but if either one of these is pushed, it's going to kill that light. So it's kind of like a combination lock, is what we just did. Thank you for watching.